Hello, Stat Nation. Remember, this is our standard deviation symbol. This is Chapter 3, Day 1. Chapter 3, Day 1. We are getting into bivariate data. Bi meaning two, like bicycle, two wheels. So we're getting into bivariate data. So let me share my screen with you. This is a pretty cool chapter and a very important one, as so much data is displayed in a bivariate nature, so much of it. I'm getting my annotation ready as well. So during this video, feel free to stop the video at any time, and you'll need to catch up on the notes, to write it down. I'm also going to be doing some calculations on the calculator, so make sure you have your calculator handy. I'm using a TI-84 Plus, and I'll try to talk slow during that, because although the calculator is simple, once you know what to do, it takes a little bit of time to get used to it. We don't really do any calculations in stats by hand. We mostly use software. That software is most likely going to be a calculator, with the high-end calculator as of 2020 being the TI Inspire, but I use TI-84 Plus. Okay, bivariate data is dealing with two variables and their relationship. Okay, so I'm gonna make myself a little bit bigger. There we go, that's better. Okay, the typical bivariate display is a scatter plot. That's almost the only way you display bivariate data. And you have the X and the Y axis, and you're almost always in the quadrant 1, because you're not really dealing with negative variables, because data is always positive. So the explanatory variable is the X axis. Although we think about the word cause, the reality is it may not be cause effect. The two variables may be moving in the same direction by luck or by strange circumstances, or a third variable happens to be moving them both at the same time. But that's kind of the generic term for explanatory is cause, and the generic term for the response variable is effect. Okay, and the goal is to see if there's an association or a relationship between the two variables. And if so, how strong is that relationship? You're going to get a lot of sentence frames in this chapter to support you. And that'll start in day 2 of our lesson. For right now, we're just going over the basics, and I think this is absolutely crucial. Okay, so if you got to pause the video at this time to get those notes written, obviously feel free. Okay. So as we go forward, there's 3 key things to look at in these scatter plots, and those things are right here: the strength of the association, the direction, and the form. Okay, and I'm going to give, there's an unlimited number of words you could use for some of these descriptions. I'm going to try to limit your vocabulary, just so that we have a common language in our class. Okay, so for the strength, we're basically going to use 3 words for strength. We're going to use strong, mild, and weak. You could use strong, moderate, and weak, but something like that. Strong, moderate, weak, strong, mild, weak, fine. The direction, there's only 2 words: a positive direction or a negative direction. Okay, a positive slope and a negative slope. And the form, you're basically going to be limited to some degree between linear and non-linear. So linear is a line. Non-linear could be a lot of things. It could be an x squared plot, which is a U shape, or an upside down U. It could be a cubic pattern, which is, this is a cubic pattern, right? X to the 3rd, if you remember that. Okay. It could be an X to the 4th pattern, if you remember those. That kind of has a couple turning points. okay? It could be a sine curve. If you remember what sine is, you got the sine, you could have one of those things. There's all kinds of non-linear patterns. We do not get into non-linear data in chapter 3. We do a little bit in chapter 12. So for right now, we got linear and non-linear to make your life easy, because we want to make sure that we limit what we're studying so we can master it, okay? So pretty obvious what I'm going to show you next here. Okay, so here is forms of linear data, okay? This is obviously linear right here, okay? This is a negative linear pattern. This one is positive. So this is positive and this is negative. And this one, the lines are a little closer, the dots are a little closer together, so that would have a really strong pattern. While this one is pretty strong, but it has a little bit of variability around that line. Well, obviously, these are non-linear. They still have a pattern, but they're non-linear. Okay, that's probably some sort of x squared pattern. And you recognize this as probably a sine or a cosine curve, probably. And this one is essentially no association. I don't see a pattern there, and don't look at like clouds where you're looking like, oh, I see a duck chasing a turtle. Don't do that. Just there's no pattern there. Okay. All right. So linear, non-linear, no association. That's kind of what we're doing right now. We're keeping it real simple. Okay. All right. Now the next part, we're going real slow here, and all we're going to talk about is we want you to look at A, B, C, D, E, and F, and try to ask yourself which one is the explanatory variable, which would be the x variable, and which one would be the response variable, which would be the y. X, y, okay? Height and weight, wow. Most people think of height as the x and weight as the y. The taller you are, the more you weigh. That's typically how people think. I know there's exceptions to that, but in general, I think we realize as you get taller, especially kids, as they get taller, they're going to start putting on more weight. Okay, so think of it that way. Maybe the best way to look at it is just for kids, you know, small, from infants up through age 10. The taller they get, the more they weigh. Okay. Height and age, again, let's look at this from the aspect of children. And as a kid gets older, think kids age 0 to 10. By the way, sometimes they have domain restrictions on these for stats. This only applies from age 0 to 10, right? So as you get taller, as you get older, you typically get taller, okay? And you've seen these charts probably for your little brother or sister or something, where they have that growth chart, and it's usually done in months, how tall you should be at a certain amount of months. So that would be a good example of that. And they give you percentile ranks, like I'm in the 95th percentile of height or whatever, okay? And then house size and income, you probably realize, I know there's other factors, where the house is located. I know Newport Beach is going to be more expensive than Idaho or something, okay? But in general, the larger the house, the more income there is, okay? So, whoops, I think oh, sorry, back up. Let me roll that back. I mean how much you make, how much money you bring in. There we go, how much money you bring in, okay? So if you bring in $100,000, you're gonna have a certain house size. But if you bring in $1 million, if your income goes up, then you're probably gonna get a bigger house. That's better, sorry about that. So the more income you make, the larger your house, okay? All right, mileage of car and age of car. Erase this real quick. Mileage of car and age of car. So you probably realize the older the car, generally speaking, the fewer miles there are. There are exceptions to that. There are outliers, of course, where grandma buys a car and never drives it. But in general, the older your car, the more miles that are on it. Okay, so this is the explanatory is going to be X right here, and this will be Y down here. Okay. Weather and school attendance. Weather is a predictor of school attendance. When it's really cold, think like negative 30 degrees. The kids are probably staying home because it's a snow day. When the weather is really hot, like 120 degrees, it's probably summer, so they're not in school either. So weather does have a little bit of a predictor on school attendance, okay? 1F is my joke. I don't know which comes first, the chicken or the egg. I don't know. Sometimes it's really hard to tell which one is the explanatory and which one is the response. It can be very, very difficult at times. And so sometimes it doesn't make any difference which one it is, okay? You could even make the case for this one that it doesn't matter which one is which because they're both going to be they're responding to each other anyways. That can happen as well, okay? All right. Now, this is when you need your calculator, and I'm going to walk you through some stuff. So you can see here, let me move my picture. I'll put that right there for now. Okay. So let's look at GPA and study hours. Okay. So as you probably realize, the more study time that you have, the higher your GPA. That's in theory, okay? So the more study you have, time you have, the higher your GPA. So even though it's listed like this, this is my X and this is my Y, okay? So my explanatory response variable are flipped on the chart, okay? So what I need you to do is I need you to type these into your calculator, okay? I'll show you how to do this. This is going to go in list 1 right here. This is going to go in list 1, and then GPA will go in list 2. And you're going to end up seeing a drawing like this. I'm going to show you all this stuff, okay? All right. So let me go ahead and bring up my calculator. Okay, so here's the calculator. Got some stuff on there already. Let me move my picture. All right. So to get to those lists, remember you're going to go stat, and if you're having trouble, I hit the button that turns red, and then hit enter, and you're going to see a bunch of lists. And I have preloaded the data, so I've already done it. So again, you'll probably have to stop the video and go ahead and load everything up in your calculator, all right? So this was the study hours, and this was the GPA. Now, do not sort the data because these are a coordinate pair. And if you sort the data, that's going to cause problems because they don't sort that. Okay. So once you got it in order here, I'm going to go ahead and graph it. Okay. So I'm going to go second y equals, and I'm going to make sure that only plot 1 is on. Only plot 1. Okay, so I'm going to hit enter. You have to play with these sideways guys to get that done. I hit enter here, make sure it's on, and I'm going to click on this. This is the scatter plot, and when you click on scatter plot, it's going to ask you for 2 lists. Which lists do you want? I want X to be the L1 list and Y to be the L2. I typed it in the way I wanted it. Okay. Once you have that list in, remember to do this, to get L1 there, you're going to go second and the 1 button. Notice that the blue L1 is right above it. So the second function of the number 1 is the list of L1. Same thing here. I'm going to go second and the 2 button, and that's going to tell the calculator that L2 is the response variable. Then I'm going to go zoom. And I'm going to go to the number 9 because number 9 is the statistic. Zoom stat, it'll make the window, okay? Okay, zoom, there it is. Now, you have to admit that looks pretty linear, okay? That looks very, very linear. Let me just go ahead and draw a line on there, okay? This looks extremely linear. Now, during this chapter, we are going to talk about the line of best fit. Now, the line of best fit, when the data looks linear, is pretty easy to draw. You could just kind of middle the numbers and you'll find it's no problem at all. I don't want to get into it too heavily here on day one. However, it's good to just to kind of mention that when you develop the line, and the line that we will use is called the least squares regression line. Least squares regression line. And most people just say LSRL. That's all they do, because it's like physical education. We call it PE. It's pretty similar. Okay. So that line of best fit is done with software, and I will show you how it works at a later time. But there is a line of best fit. Now, the line of best fit is one thing, but there's a statistic called R. And R is the correlation coefficient. Coefficient. There we go. R is the correlation coefficient, okay? And that number tells you how well the line fits the data, okay? So if it's a perfect line, R is going to be 1. If it's a perfect negative line, it'll be -1. And then it starts getting decimals towards 0 for effectiveness. And we're going to spend the remainder of the time basically explaining this, okay? So R is called the correlation coefficient. It's often just called the correlation. People often just call that. Why they use R instead of C for the symbol, the reason is in statistics, C is the coefficient for x squared. It's already used. They use R, okay? And I guess you could look at it as there's 2 R's in correlation and only 1 C. I don't know. So, but that's kind of they use, it's R, okay? And there's also a stat called R squared. R squared is derived from the same calculations, but has a different meaning. And you're going to get all of this. Chapter 3 has a ton of vocabulary, and I will support you with sentence frames heavily, so you'll be fine. But you'll be learning kind of a new language, which happens a lot in stats. All right, so I think here's the line, but I want to know, how good is that line? And the calculator will do it for you, okay? So watch closely. I'm going to go stat, and I'm going to arrow over to calculate, and then I'm going to go down to number 8. Now, number 8 says linear regression, A plus BX. You guys are used to, for lines from your algebra days, you guys are used to y equals mx plus b, okay? You're used to that, where m is the slope and b is the y-intercept. That m comes from a French word meaning to climb, but I don't remember the word, okay? But that's where that word comes from, that letter comes from. In stats, we use a as the y-intercept, a is the y-intercept, and b is the slope. So you got to get used to that. I want to point out that item 4 and item 8 are actually the same exact thing. Just the only difference is 4 has a as the slope and b is the y-intercept. Don't use that because I don't want you to be confused. Please use 8, where a is the y-intercept, b is the slope. Okay? All right, so anyways, let's back that up again so you can see it again. I'm going to go second quit. I'm going to go stat, arrow over to calculate, and I'm going to click on number 8. And then I'm going to tell it that I want X to be L1 and I want Y to be L2, okay? And then I'm going to hit calculate. Now, I'm not going to focus on this right now, but notice it gives me the line of best fit. And the line is Y equals, and I'm going to negative 2.79 plus 1.7x, okay? It gives me the line. I'm not going to focus on that. What I want to focus on is the R value. And the R value, if it's linear, is applicable, okay? So I'm going to focus on the R value, and that R value is about 0.92 if I were around, all right? 0.92 is fairly close to 1. 1 would be a perfect correlation where all the points are lined up. So this data is almost perfectly correlated. It has a very strong association, okay? All right, so let me go back to the notes now. So you can see if I were to draw a line in here, and I'll go ahead and do that, that line right there, okay? The R value was very strong, okay? So if I were to make a statement regarding the display, when you make a statement, there's gonna be 3 things you talk about. You're going to use one of 3 words where the arrow is. You're going to use the word strong, you're going to use the word mild, or you're going to use the word weak, okay? And I will give you barriers as to where you use strong, mild, and weak. But this one is definitely strong. 0.9 is strong, okay? So you're going to use strong, mild, or weak here. The second word you're going to use is you're going to use the word positive or negative. Now, if the trend has a positive slope, you'll use the word positive. If the trend has a negative slope, you use the word negative. And the last word you're going to use, if the data is linear, is the word linear. Okay? So here is my sentence frame. There is a strong, positive, linear association between study time and GPA. So if they ever ask you, make a statement regarding your display, this is the sentence frame. This is the structure. And we're going to go over that at a later date, but I'm just introducing it here. Okay? All right. Now, let's go ahead and look at sleep hours and shoes owned. You got to admit, how much you sleep and how many shoes you own, they may not have any relationship, and they're probably not related in a linear fashion. So I went ahead and put this on my calculator, and I got an R squared value, and then I made a sentence. But let me go ahead and show you on the calculator once again how I did that. Okay. So I'm going to bring the calculator up, move me out of the way. I'm going to go stat enter. Now I put these in L3 and L4. I could have put them in L1 and L2 and erased those, but I put them in L3 and L4. And I really don't know which is which. So I just put them in there as they were. I really didn't know which ones to put where, okay? So, because I don't see any connection between them. So I don't really know which one's response and which one's explanatory. All right, so I'm gonna go second Y equals, and I'm gonna graph these. Same setup. Remember, I'm going to go second L3 and second L4, right? Okay. And there's the graph. I mean, you know, there's not much there. I guess you could say there's a little parabola there, I guess. This could be no association or parabolic, I suppose. Either answer would be fine by me. Okay, so in any event, let me go stat calc 8, L3 and L4, right? Let's go ahead and get this R squared value. I got a really weird R squared value of negative 0.2638, okay? Now, on here, I got an R squared of 0.5525. And this is how I got that. Let me show you that, okay? So this is a little different, because remember I told you, I don't really know which one's explanatory response. So let me just do it the other way. Let's go stat calc 8, and I'm going to tell it L4 comma L3. So I'm going to switch explanatory response, because I just don't see a connection between shoes owned and sleep. I just don't see it. So that comes out a little bit different, okay? All right, in any event, okay? Yeah, this is crazy. So that value is right here. Okay, so anyhow, there really isn't any association. There's just simply none, okay? So my sentence is, there's a weak parabolic association between hours of sleep and number of shoes. Fine, no problem. All right, slide down here. Let's now talk about the correlation coefficient, or R. Let's talk about it. Okay, this is really cool. All right. R measures the quality of the line, okay? And check this out. It's a crazy formula, okay? It's actually the product of the z-scores of x, the z-scores of the y's divided by n minus 1. It is crazy. You will never use this formula, ever, okay? But in theory, it's the sum of the products of the standard deviations, okay? But what you got to know is it ranges from -1 to 1, okay? It's got two directions, positive or negative. Now, these are the values. We're going to say strong is 0.8 to 1. We're going to say moderate is 0.6 to 0.79, and weak is in there, okay? So we got strong here, and we got strong down here, right? Okay, if I change colors, we got moderate in here, right? And moderate in here. And if I change colors one more time to something else, like, come on, like that, we got weak in here, okay? So when I say 0.8 to 0.1, I also mean -0.8 to -1 is also strong. There's perfect negative and perfect positive. So I kind of put that on a continuum. All right. So, and this formula is crazy. Look at this. You're going to take every individual x minus the mean of the x's, divided it by the standard deviation. If you think about it, isn't that the definition of a z-score? Do you remember that from chapter 2? That's what it is, right? X minus mean divided by standard deviation. And then you take the corresponding y, every y sub I means every individual y, minus y bar, which is the average of the y's, okay, divided by the standard deviation, okay? So basically it's a 2 z-scores, but you'll never do this, ever. It's all done with the calculator. There's no way you would be able to do that by hand. It would take forever, okay? Couple important things here, all right? There are no units of measure. It's not like miles per gallon, there's nothing. The reason that there aren't any units is because typically X and Y have different units. So like study hours in GPA, study hours is units of an hour. GPA is GPA units, right? but we don't say hours per whatever. We don't really do that. So for R, it's just a relationship, okay? Now, this is important. R is only for linear models. If it's nonlinear, do not refer to R, okay? And R is tremendously affected by an outlier. For example, okay, here is a perfect correlation that has an R value of 1. You add an outlier, that R value is going to drop tremendously, okay? All right, common errors here. Correlation is not necessarily causation. It could be causation. It could, but it could be coincidence. It could be something else is driving both variables. Let me give you an example of this, okay? Smoking and lung cancer. The more you smoke, the more likely you are to have cancer. That's probably cause, and it's been proven over the years by the Food and Drug Administration with their experiments, okay? Another one that has strong correlation, ice cream sales and drownings. As ice cream sales increase, drownings in pools at the ocean, they also increase. That is not cause effect. What's going on is heat is driving both variables. As it gets warmer, people buy more ice cream. As it gets warmer, people drown. But it makes it look like ice cream's causing it, but it's not. It's just correlated, okay? All right. Another one that's temperature and crime are related. As the temperature goes up, crime goes up. That is not because temperature is causing crime. It's because it's very difficult to rob a bank in a snowstorm. It's very difficult to maybe you can't have a war. It's hard to have a war in the winter. It's hard to do those kind of things. So getaway cars are a lot easier to use in the summer than the winter. So that's why that happens, okay? Also, people leave their windows open in the summer because it's hot and it's easier to break in. Okay, R is not the slope. It's just the strength of the linearity. And again, it's not applicable to the curve relationship. Okay. Last part. Hope you enjoy this as well. Last part. We are going to look for the correlation for each value. And I'm going to limit you because there's it's obviously limitless, but here are the numbers that you get to pick from, okay? You only have some to pick from, all right? So just pick from these. And it can be debatable, okay? I think it's pretty obvious that this is 1 because the points are perfectly lined up. It is a line, and it is a positive line, so it's positive 1, okay? This is a negative trend. A negative trend is when X goes up, but Y goes down, okay? So as X increases, Y is decreasing. That is a negative relationship. And you can see that these points do not line up perfectly, but they're close. So I said that was negative 0.8. So that's a strong negative linear relationship. Remember my sentence frame? There is a strong negative linear relationship between, I don't know what X and Y are, but I could say strong negative linear relationship between staying out late and your GPA. The longer you stay out, the GPA drops. How about that? Okay. This one, again, I have as a R value of 1. Okay. And maybe this relationship could be height and weight of children. There is a strong positive linear relationship between the height of a child and the weight of a child, between 0 and 4. That'd be a good sentence frame for that, okay? The next one, next set here, okay? I'll go with this one right here, okay? So on this one, I set it 0 because there's no association. So let's just say this is if they were asked to describe the association, let's say X and Y were how many shirts you have in your closet and your running speed or something, all right? And the sentence frame would be, there is no correlation between the number of shirts you have in your closet and your running speed, okay? This one is interesting. It's negative for sure. And I want you to notice something. I put this right here, but because there are two outliers, it's actually artificially makes it look like we have more correlation than we may have, okay? These 2 points would be called influential points, okay? Because they are not near the other ones, but they are making R look artificially large. So again, these are called influential points. And I didn't know, I didn't do the calculation, this is somewhere in here. But it's probably in the weak area, okay? Mild or weak, so either one would be fine. There is a mild, negative, linear relationship between X and Y, whatever that is, okay? F is a perfect correlation. Even though there's no dot here, those points still make a line. I managed to miss it, but there we go. Makes a line, perfect, okay? All right, so there is a strong negative linear association between X and Y. And when you do that, make sure you say what X and Y are. Put it in context. There is no context here, but please do that when you get that chance, okay? All right. We got a few more. We're almost done. All right. So let's go to G right here, G. All right. So with item G, there's a pretty good negative relationship here, okay? But it's not super strong. I would say it's moderate. So my sentence frame would be, there is a moderate negative linear association between X and Y, okay? This is a cool one, okay? This has a real strong relationship, but it doesn't have a strong relationship linearly, but it does actually have a really strong trend to it. But for a line, it's R is 0, there's nothing. There is a, so in this case, you would say there is a non-existent linear relationship between X and Y. Okay, this is clearly going to be parabolic. Okay, this also is probably R is 0 because it's not linear. Okay, but it probably has a perfect sine curve. Okay, or cosine, whichever one. All right, this one. This has a little bit of at least a negative trend. It's sort of trending toward, as X increases, Y increases. That's a negative trend. So I put it in the kind of the weak category. So there's a weak negative linear association between X and Y. This one, it probably has a good fit. This is probably a square root one, if you remember those, okay? But there's kind of a linear trend there, and I didn't know which one to pick, so maybe I'd pick 0.6. Let's go with that one. So that would be, there is a moderate linear association between X and Y. And then again, this one probably has a good pattern to it, but it has some linear qualities. And I would say I'll go with negative 0.8. There is a strong negative linear association between X and Y. Okay, that is day 1 of chapter 3. So I stop that real quick. I hope you guys enjoyed that, and we'll see you next time. Stat Nation out.